Hi grade 8, this is just the last video recap of the work done in unit 11 for those of you who have done it. You can go back for those of you that are starting it still, and this is just a guide for you through the PowerPoint slides. So these are the slides, and then if you want you can use the notes on the side, but these are the PowerPoint slides. So this is about quadrilaterals. Now the word quad means four. And so a quadrilateral is specifically a polygon, a closed shape with straight edges. That's what a polygon is, but specifically one that has four sides. So a polygon is a closed shape with straight edges, but then a quadrilateral specifically is one with four sides. So think about the different quadrilaterals that you've learned about in previous years. Okay, so you have squares, rectangles. What else would you think of? There's kites, there's trapeziums. So some of you have learned a little bit more about different shapes than others. So we're going to go over the important shapes together. So these are the ones that you must know, please. So when we're looking at quadrilaterals, you need to know what a rhombus is. You need to know what a rectangle is. You need to know what a square is. A trapezium, a parallelogram, and a kite. If you've heard about these before, great. If not, the notes do show you what they are. All right, so just very importantly, all interior angles, inside angles of a quadrilateral will add up to 360 degrees. So if I give you a random shape here, and you're given some angles, so there's 170 degrees, 80 degrees, 96 degrees, and then an unknown. All of these angles, these four angles, add up to 360. So 170 plus 96 plus 80 plus, let's call our unknown x, is equal to 360 degrees. So to get x by itself, remember we move over to the other side and we use the opposite operation, the opposite sign. So x by itself is going to be 360, take away 170, take away 96, take away 80, which is 14 degrees. So all of your angles add up to 360 degrees in a quadrilateral. All right, so please, you must know that rule. And there's an exercise on this on page 119 or 111, depending on the textbook edition you have, but it's exercise 11.3, so find it in your textbook. And so if you have a look at it, it's just sort of the same thing that I've worked with, just a couple of more X's. So remember, you group like terms, and then you work through the like terms and get X by itself. All right, so you can come back to this memo. It is also posted on your Google Classroom page, and if you need help, please contact your teacher with it. All right, then there's also a little informal test in the slides. The answers are given, but it's just something extra for yourself to work through. And then this should, just say add up to. So if you again need help, you can speak with your teachers. Okay, this is the more important part. So the properties of a quadrilateral. So what makes a certain quadrilateral special? How do we define them? How do we categorize them into different types of quadrilaterals? So it's got to do with their properties. So firstly, you need to know what a diagonal is. A diagonal is a straight line that goes from one corner, a point is a vertex, to another, but not along an edge. It goes through the inside of the shape. That's a diagonal, and that's a diagonal. Right, so that's important. So now let's look at the parallelogram specifically. A parallelogram looks kind of like a wonky rectangle. So firstly, you need to know that two pairs of opposite sides are parallel, meaning they are the same distance away from each other. They'll never meet. They'll never change their angle or their slope. They're going to stay the same. They are parallel to each other. The opposite sides are equal to each other, very similar to a rectangle. The opposite angles are equal. So if this one is, let's say, 110, that will also be 110. But then let's say this one's 70, that one will also be 70. But remember, all 4 of these angles, whatever they are, must add up to 360 degrees. Then for number 4, their diagonals bisect each other. They cut each other in half. So where they cross here, it makes equal pieces. So these little lines mean equal pieces. So let's say maybe that is 3 centimeters, that is 3 centimeters. This is saying that these are equal to each other, but not equal to the other one line one. So maybe this is 5 centimeters and 5 centimeters. Right, so they cut each other in half. Okay, perfectly in half. Then a rhombus is a parallelogram that's kind of been squished. It's almost like a square that's tilted sideways. This here, though, your diagram is a little bit squiffier. The line should be a little bit more sloped like that to be parallel to its opposite side. Same thing here. All sides are equal. So let's just try and get rid of some of this. And so the fact that they all have that single line attached, so this line here, that they all have the single line attached, that's saying that they are all the same. It's like a way of marking that they're all the same. Again, the opposite angles are equal to each other. All right. But because the blue one only has 1 dot and the green one has 2, it's saying that the blue and green are not the same as each other. Okay, just the opposites. Diagonals again bisect each other. So this piece will be equal to this piece. But this piece will be equal to that piece, but not to the green. Right, the diagonals aren't the same length. And I mean, you can see that if I draw a rhombus. That's terrible, sorry. A quick rhombus. Right, this diagonal is pretty long, and then this one's a lot shorter. If you use your ruler to measure, you can see it. Now, remember, your diagrams aren't ever really drawn exactly with the right measurements, but they will be in proportion. So if it's supposed to look like they're equal, they will look equal and parallel. Then this diagram just kind of came out a bit funny here. The diagonals intersect at right angles. Okay, so what that means is all 4 of these are 90 degrees, all 4 angles there. So they not only cut the diagonals in half at that point, but they also have a 90-degree relationship there. Then diagonals bisect the opposite angles. So they'll cut the angles in half. So if this is 100 degrees as the big angle, it will break into 50 and 50. 50 and 50. If this, let's say, was 60 degrees to start, it would break into 30 and 30, 30 and 30. All right, so it breaks it up. It's really handy to use, and you must know these properties so that it makes it easier to answer the questions when they ask you what type of shape is this, and they give you all these clues. Rectangles, you should be familiar with a rectangle by now. Opposite sides are parallel. The opposite sides are also equal. So there's a long side and then shorter sides. Those are equal. Again, here the angles are just a bit weird. You have right angles here. Okay, so they are 90 degrees. Right angles. So each corner is 90 degrees. And think, all the 4 corners add up to 360. And so 90 plus 90 plus 90 is 360. The rectangle is pretty special. It has equal diagonals. So the diagonals are the same length. And they cut each other. So they cut into 4 equal portions. They're all the same as each other. Okay, so rectangles nice and easy. Squares, also quite nice and easy. Your opposite sides are parallel. All sides are equal to each other. Your corner angles, your interior corner angles are 90 degrees to each other. Or not 90 degrees to each other, sorry, 90 degrees. And then your diagonals are going to bisect each other, and they are also equal in length. So this is very similar to a rectangle, except all four sides are equal. All right, so then we're working with equal diagonals, and they split into 4 equal bits. But here's where the difference is now. Our diagonals are going to cut at 90 degrees. So all those little angles there are 90 degrees. Then also the diagonals bisect each other, but because these corner angles are 90, it means each little piece is 45 degrees. So each broken in half piece of your square's corners are 45 each. Okay, a trapezium, there's not much you need to know about a trapezium. It's just a 4-sided shape with 1 pair of parallel sides. Okay, remember, parallel sides, they will never meet, they'll never change their slope. So you can see they are very definitely the perfectly straight lines here. All right, so that's all you need to know about a trapezium. A cut is a quadrilateral with 2 pairs of adjacent sides equal and 1 pair of opposite angles equal. Okay, now let's talk about the adjacent. Adjacent means next to. Directly next to. So this one and this one are equal to each other. This one and this one are equal to each other. Then with the 1 pair of opposite angles equal, we are looking at specifically these angles over here are equal to each other. Remember, we use a loop and we're just showing the same color that those two will be equal. All right, great. That is the quadrilateral work for exercise 11.5, categorizing using these properties to match up and categorize the different types of shapes. Okay. And then you're just doing number 1 and number 2A to F. So in the exercise, you can see it's asking you what sort of shape you are looking at. So the whole of number 1 and then 2A to F. Don't worry about H. H is not something that you need to worry about right now. So if you do the rest, just leave off H. All right, grade 8, that is unit 11 covered.